I hope the lesson is going very interesting. Okay, now I told some of the terms, important terms related to the spherical mirror we are going to discuss in this next video. So first term, that is regarding the spherical mirror, pole. We have pole of a spherical mirror. This is nothing but the center of the reflecting surface of a spherical mirror is a point. That point is called as a pole. So I can say the center of the reflecting surface, the center of the reflecting surface of a spherical mirror, is a point, and it is called as pole. Okay, and the important thing is it lies on the surface of the mirror. Is it clear? It lies on the surface of the mirror. This has to be noted because you should not have a confusion whether the pole is lying on the surface or not. Suppose I take this mirror and this is the rough surface and the inner is the reflecting surface. Okay, so what type of mirror it is, whether it is a concave or convex, if you are able to tell now correctly, means you are observing it correctly and you are memorizing the fact then and there. And if you are not able to tell now, then from now onwards you have to follow one principle, that when you listen itself you have to memorize instantly. That is a secret of your success, because if you remember, if you observe then and there, and if you remember it better, it will be very much helpful for you for the exam. Okay, so what type of mirror it is? The reflecting surface is inside, so I told it is concave, isn't it? Many of them might have answered it correctly before, so it's good. So it is a concave mirror where the reflecting surface is inside. So the spherical mirror whose reflecting surface is curved inward is known as a concave mirror. So by definition. Okay. So the pole will be a point on the surface. It is the center of the reflecting surface. So I will put P. Normally the pole is represented by the letter P. So now you understood one term, that is pole of the mirror. So you can, if somebody asks you what is the pole of the mirror, you can able to explain them very clearly. Okay. Now we have center of curvature. That is the second term associated with the mirror, is the center of curvature. Center of curvature. Center of curvature, we can understand that, suppose if this is the spherical mirror like this is the rough surface outward and reflecting surface inward. So what type of mirror it is? Convex mirror, am I right? No. Concave mirror, yes. So same diagram, so I have taken the same mirror. It's a concave. Okay, now I am marking some point here. What is that? Nothing but pole. Clear? Okay, so we are going to see a new term here, that is nothing but the center of curvature. Suppose if I extend this mirror, there is a curvature, right? I am extending this mirror completely to form one circle. The center of the circle will be somewhere here, and that is nothing but the center of curvature. I will put a letter C for that. Okay. So you learn two terms now. One is pole, one is center of curvature, and you can very well explain to others better than me because you are observing very clearly. So you know what is pole and you know what is the center of the curvature. Okay. Next comes the radius of the curvature. That is the third term associated with the spherical mirror. That is nothing but the radius of curvature. Very simple. What is radius of curvature? Again, I will go back to the same diagram. Okay. So now I have a mirror like this, and the rough surface is here, and here it is the polished surface. First of all, I want to ask you one question. What type of mirror it is? Convex. Good. No. Is it convex? Polycylindrical surface is inward, so it has to be concave. You understood? Because you can have a mirror either like this or like this. Okay, so the polycylindrical surface is inward in both the case. Is it correct? So polycylindrical surface is inside in both the case, so it is concave. So don't get confused between concave and convex. Okay, actually we are going to see the radius of curvature. This is just for the basics I told. Okay, so don't get confused between concave and convex. Now we have a concave mirror, so no confusion for you. And I am marking this point. You have to tell what is this point. What is this point? And what is this point? I'll put P and I'll put C. You know it is pole and you know it is center of curvature, isn't it? How we got the center of curvature? Because if I extend this and if I complete one circle, that center will be the center of curvature, center of the sphere. Okay, fine. You know everything. Now the radius of curvature is nothing but the radius of this circle. So that is represented with R. So it is basically the distance between the center of curvature to the pole. Okay. So now you know three terms. One is pole, one is center of curvature, and other is the radius of curvature. Okay. Hope the lesson is going interesting for you. Now we have one more term called principal axis. The term, fourth term we are going to study here is principal axis. This is nothing, it's very simple. It is just a line joining the pole and the center of curvature. Okay, so if you join a line through the pole and the center of curvature, that line is called as the principal axis. Okay, so I'll put the diagram here. So if you want the definition, you can write it from the diagram itself. We have a mirror. Okay, and we have a rough surface here. What type of mirror it is? Concave. Okay, and we have a pole, and we have a center of curvature. Okay, and I am going to join a line which is passing through the pole and the center of curvature, and this line is known as the principal axis. Is it clear? So the line passing through the pole and the center of curvature of the spherical mirror is known as the principal axis. Is it clear? Fine. Now the next term we are going to read is aperture. What is meant by aperture? It is nothing but the diameter of the reflecting surface of the spherical mirror. So it is the diameter of the reflecting surface of the spherical mirror. Is it clear? It is nothing but the diameter of the reflecting surface of the spherical mirror. Okay, and we have one relation connecting the radius of curvature and the focal length. So I will write here relation between R and F. F is nothing but the focal length. Oh, we have not discussed what is focal length, isn't it? What is focal length? So first I will talk about what is focal length. Okay, then we will see the relation between the radius of curvature and the focal length. So now I will take this statement out.